Probably one of the most difficult extension spring problems we had was for barrier springs. These are big extension springs that are used to lift the barriers up when they put barriers around a application. We have a series of big springs around the World Trade Center that will pop up a barrier to prevent anybody trying to drive towards the building or even towards Memorial. So they'll take big, heavy extension springs to assist lifting these big plates that will keep any type of truck from penetrating the area around the World Trade Center. We use them all over the world. We're even out in the desert around oil fields. They put them in different spots and they pop up automatically by the spring and prevent anybody from getting into the oil field application. The problem was they would probably work 3 or 4 times and break. And so they came to us and we looked at the application, and it has big plugs screwed into the end of it so we can use real heavy wire springs. What we did is we came up with an inner and outer arrangement that was able us to optimize the forces for the application. We made the springs open wound so we could shot peen them and get a much better fatigue life and also get the coating between the coils. So we ended up with a spring that was about 4 feet long, about 6 inches in diameter, weighs so much you can't lift it up yourself. Put it together and think about an inner and outer spring acting as one, screwed in with plugs. And then we put a big bolt in the end of it, and that attaches to the 2 parts that lift up the barrier. But we were able to do that for this customer, and knock on wood, we've had 0 failures because of the reduced stress in the spring, the shot peening, and getting the paint in there all together, and we give them enough force to actually lift up these huge plates in a very quick response. We had another application where we're using a spring for a valve that's called the steam reclaimer valve, and they're used in steam and all different types of wet applications. And the customer was having a hard time, the springs kept breaking. So we looked at the application, and first we eliminated the hook design. We went to a plug design where we screw the plugs in, and then we looked at the application. And the tricky part with this extension spring is it had to have initial tension, because not only was it stretching, but it was also bending in the middle, and that bending is what actually made the valve close up and open. We tried stainless, and stainless wasn't good enough, so we came up with a pretty unique design out of Inconel 718 with screw-in plugs that also gave you initial tension. And since we did that, the customers had 0 problems, had 0 breakage, and what he has is a very reliable product, because these steam reclaimers are sometimes out in the middle of nowhere, and if it spring breaks, they've got to send a crew all the way out to replace it. Since we've changed this design, they've not had to do that once, so it's a pretty good success story.